Black holes were first predicted in 1916 by Albert Einstein's general theory of relativity, providing a unified description of gravity as a geometric property of space and time. Einstein's theory has important astrophysical implications. For example, it implies the existence of black holes, regions of space in which space and time are distorted in such a way that nothing, not even light, can escape. Everything in the universe has what is called a Schwarzschild radius, a tiny amount of space where, were you to compress the pure mass of the object into, its density would become infinite, so its gravitational pull would be so strong that nothing could escape it, not even light. For example, were you to compress Mount Everest into the size of a nanometer, or were you to compress the Earth into the size of a peanut, you would get a black hole. When a star runs out of fuel, it will collapse in on itself under the force of gravity. This inward pull will condense the mass of the Sun into an infinitesimally small point known as a singularity, where the density is infinite. If anything comes within a certain range of a black hole, called its event horizon, it would be impossible to escape the black hole's gravitational pull. It's at that point where light can no longer escape. The person watching you fall into the black hole would see you descend slower and slower until you would be frozen in space, the light coming off of you becoming increasingly redshifted until you vanished into nothingness. They would never actually see you cross the event horizon. The closer you get to the point of singularity, the more significant the difference between the tidal forces of gravity becomes. Parts of your body closer to the singularity will be pulled more strongly towards it than parts facing away. This is known as spaghettification, tidal forces becoming so extreme that they exceed the molecular forces that bind the flesh. As you snap into two pieces, and then those two pieces snap into another two pieces, until the forces start to rip your atoms apart, until you are just a stream of atoms moving closer and closer towards that point of singularity.